Okay, here's another video demonstration, and this one again is meant to give you the impression that any type of motion or force acting along a horizontal axis is completely independent of any type of motion or force along a y-axis. So the challenge is for the two of us to lift this bowling ball, all right? And we're gonna pull until the rope goes totally straight. So we just need to pull a little harder. So here we go. This is a pretty good effort. Okay, pull harder, harder. Ugh, there's no way here, they'll walk in closer. Maybe that's the problem, is we're too far away. Closer, closer, closer. Okay, now let's pull it flat again. Dang it, I don't like that sag. How do we get rid of the dip? Ugh, of course not. Okay, the problem here is that we have a force of gravity that pulls in the vertical direction. And if we were able to get the rope perfectly flat, then I would be pulling with a force along the positive x-axis, and my assistant would be pulling with a force along the negative x-axis. And that's fine. Those two forces could cancel each other out in this tug of war, but what's left to offset this downward pull of gravity? There's nothing. But if a sag remains in the rope at all times, even if it's slight, if we pull hard enough, that little bit of inclination that shows up on both sides of the rope, they have components to the right and to the left that cancel one another out. And you see there's still some lingering upward component from each of these efforts. And it's the combination of those upward components that provides the offset to this force of gravity. So just one more demonstration to help you appreciate this idea that horizontal and vertical motion can be treated independently.